being able to evaluate information is a foundational skill for all scientists. You need to have well-developed critical thinking skills to be able to test the quality of scientific information, whether that information is in a scientific journal or whether you come across that information in the media. In this presentation, we are going to step through an article together to see how critical thinking can work in practice. Despite much evidence in the literature about the importance of critical thinking in the workforce, not many universities teach students what critical thinking is, and more importantly, how to do it. We're going to use an online blog post called "Can't Sleep, You Can Blame It on Your Parents" to demonstrate how you can critically analyse scientific information. We're going to evaluate the veracity of the arguments presented in the media against the criteria for critical thinking through its practical application. Remember, in the baloney detection kit, it said, "Does the source make cinema claims?" Well, let's check that out. So first, we're going to identify the claim that the blog post is making. The first paragraph says, "New research suggests that if one parent suffers from insomnia, there is a 35 to 55% chance that the child will too. For twins with chronic sleep issues, that figure is somewhere between 42 and 57%. Failure to get a good night's rest, then, is often a family affair." So the claim that is being made here is that sleeping patterns are genetically influenced. Next, we're going to consider the source of the research or claim. If you notice, the blog post doesn't give us a link to the original research. When we Google a part of the text in the first paragraph, we find that the blog article is actually based on a newspaper article in the Telegraph by the same author. It's no wonder it's difficult to verify claims made on the internet. It's common for the source of information not to be disclosed. The effort that it takes to validate information is usually too much for most people, and that's why we have so many people believing false or inaccurate information. When we look at the online newspaper article, we can see that it has a link in the words "latest research." So if you click on that link and follow it, it takes you to an article on a website which shares the latest science research news called Daily Science. Now, the publisher of the website is Springer, and Springer is a widely respected publisher of academic science journals. So that's a really good sign. What you can see is that when we get closer to the scientific evidence, we start seeing the sources of information becoming more well documented. The reference has to give you enough information to find the article. And to ensure this happens, we usually use a standard format that's agreed upon. And at the moment, the critical things you need to learn about that is that you have to at least have who, when, what, and where. So who was the author? When was it published? What's the title or the topic of publication? And where was it published? And we need to have enough information so that the reader can actually go back to the original evidence to check if they're interested. Later on, you'll be required to use an official style. And this means that you don't inadvertently forget critical information. And that's really an important part of science. And we've got an example here, which is showing how to do APA style. When we look at the Science Daily article, it will give you the full reference of the original scientific publication. So you can see that in this paper, we had Murray Stein as the lead author, or the person who led the research and contributed most to that research. And then we have a whole range of other collaborators who also took part in the research. We see that the document was published in 2018. There's a title which says Genome-Wide Analysis of Insomnia Disorder. We can see it's published in Molecular Psychiatry. And there's this thing called a DOI, and that's a Digital Object Identifier. And the DOI is a string of numbers and letters and symbols used to permanently identify an article or a document and link it on a website. So now we have enough information to start making some judgments about the quality of the science behind the claim that's made in the media. And there are several factors we can explore. So let's do that together. And the first thing we're going to do is have a look at the journal and its quality. So there are several ways we can get an indication about the quality of a scientific journal. First of all, we can gain some confidence in the fact that it is actually a legitimate science journal by checking in Beall's list, and Beall's list documents a list of journals which are not scientifically rigorous. We don't find our journal Molecular Psychiatry in this list, which indicates that it's a legitimate science journal. This means that this article has had to withstand the review process of other scientists who checked the method and the claims the paper made. Remember, one of the criteria in the baloney detection kit was, have the claims been verified by someone else? When we look at the URL, we see that this journal is part of the Nature research journals. Now, Nature is one of the most highly ranked science journals in the world. We can also look up the journal in SJR, which gives you a lot of data about it. For instance, we can see a measurement called the H-index on the top right. This tells you that this journal has a very high H-index and therefore seems to have a very high reputation. Right at the bottom in the middle, you can also see that this journal is a Q1 journal. This means it's in the top quartile or top 25% of journals. So we can conclude that generally this journal seems to be of a very high quality and that it gives you some confidence about the article. So let's go back to the article now. When we go back to the article, we can see that there are also some additional data about it. These data tell us a bit about the scientific impact of the article. At the top right, under the blue bar, you can see that this article has 2 citations. This means that 2 subsequent scientific articles have referred to this article as supporting evidence. The more than an article is cited, the more it indicates that other scientists think the information in the article is important. Mostly this is because they think the article and its findings are of high quality, but not always. It may also be that they strongly disagree with the evidence in the article, so it's worth following up the citations to check. Usually 2 citations is not much, but you might notice that this article is only new. It was published in March 2018, and that means there hasn't been much time for the findings to be integrated into subsequent articles. So actually, in such a short period of time, 2 citations is actually really quite good. Underneath the blue bar on the top right of the article, you'll also notice something called Altmetric. This is a way of measuring the broader online impact of the article outside the scientific sphere. If you click on the blue link to the right, it will take you to a page of data about the impact of the publication. On the right, you'll see a colourful round diagram which breaks down the various types of online impact. you'll see that the article has been retweeted 34 times and 4 blogs have been written about it, and maybe 2 of them are the ones we've read from Science Daily or Essential Parenting. Altogether, this article seems to have made quite an impact. Underneath the colourful round diagram, we read that the article is in the top 1% of similar aged articles in scientific journals. See how the Altmetric can account for the age of the article while the citation data can't. Next, we can gain an idea about the scientific validity of the paper by examining the authors. If we go back to the article and click on the authors, we see that they all come from reputable organisations. If we click on the lead or first author, usually the main author who took a leadership and did the most work in the research, we can see that there are a number of links to more information. If you click, for example, on Google Scholar, you're provided with some data about the author. You'll see at the top right some data about citations. This tells you how many times Murray Stein's research has been referred to by other authors in subsequent publications. Dr. Stein's work has been cited over 72,000 times. That's a lot. He also has a very high H index, which is another indicator of the impact of his research. The acknowledgement section at the end of the paper tells us that the research was funded by the Department of Defence. It is important to know who funds research because this may indicate a conflict of interest. For instance, the funding body may have an interest in a particular outcome which is good for future business. This can sometimes be the case when large pharmaceutical companies, for instance, fund or undertake research, the outcome of which would influence their profitability. In this case, it is difficult to see any conflict of interest in the funding from the Department of Defence in this research. Remember that one of the criteria in the baloney detection kit is use a reliable source of information. We'll now check the source of the information and investigate the evidence presented in the article itself. We can make a quick check on the currency of the information by checking the Retraction Watch database. If an article is published and an error is found after that publication, you might find it on Retraction Watch. Next, we need to investigate the purpose of the study. This article doesn't state a formal hypothesis. This is common for some fields of science, but we can see that there is a very clear aim documented in the introduction. We can convert these aims into an equivalent hypothesis. So the null hypothesis in this paper says that there's no genetic influence on insomnia. The alternative hypothesis is that there is a genetic influence on insomnia. Remember from our video about using scientific method in everyday life, it said a hypothesis is a bit like a guess about an observation that can then be tested. As we will see later in the course, usually the null hypothesis is typically something we want to disprove, since experimental science is generally a process of falsification. It's a bit like assuming a defendant is innocent until proven guilty. Understanding the hypothesis, or what the intent of the study is a bit like the beginning of critical thinking about the quality of the research. Our video about using scientific method in everyday life says the next step after designing a hypothesis is to design and perform experiments to test the hypothesis. The methods have to be described in a way that other scientists could replicate your experiment and validate your findings. We can see in the methods section of the paper that the approach taken in this study has been well documented. Firstly, the paper refers to an article which documents previously used approaches, and that's a really valid thing to do. And then it shows additional approaches used in this particular study. We can also see that care was taken to ensure that the research was ethical. You can also check if research involving humans or animals has formal ethics approval, and that will commonly occur near the acknowledgement section at the end of your paper. Another of the criteria in the baloney detection kit specifies that we need to question, are they playing by the rules of science? Here we'll see if they are using the tried and tested approaches of science, such as logic, reason, empirical evidence, testing, corroboration, looking for ways to disconfirm their ideas. The first thing we can check is the size of the samples used. If the sample size is small, the findings may be statistically limited. Ultimately, the number of samples required in research depends on the data being collected. So without knowing something about the data, it's very difficult to say how many samples are required. But there is an unofficial guide that says less than 50 samples might be worth following up more. Once we can say the sample size is big enough, we next need to check if the data collected is actually representative of the population we want to say something about. In this research, the population sampled were all soldiers. This raises the question, are soldiers representative of the broader population? If we answer yes, then we would be able to apply the findings of the research to the broader population. Watch out for research on mice and rats that are used to infer things about humans. Sometimes the information is not transferable. It's also good practice to check the variation within sample populations. In this study, they did a demographic analysis which broke the sample population into categories such as heritage, gender, and age. These factors influence genetic variation and so could bias the study outcomes. As we can see from the analysis in the paper, the majority of the participants were European, American, male, and young. In the baloney detection kit, one of the criteria asks, where does most evidence point to? We need to check if the evidence fits with the claim, and we need to use the full range of evidence available. It also requires us to check if the authors are providing a positive evidence. To do that, we need to analyse the data to determine whether to accept or reject a hypothesis. Now remember from earlier in the course, science is about disproving facts, not proving them. Remember also, we turned the documented aims in this study into a hypothesis, where the null hypothesis said there is no genetic influence on insomnia, and the alternative hypothesis said there is a genetic influence on insomnia. So the study seemed to disprove that there is no genetic influence on insomnia, which is disproving the null hypothesis. But did the article really disprove the null hypothesis? We have to be very careful here. This study did find correlations between genetics and insomnia. However, the authors have been very careful in their conclusions to ensure that they do not infer that a correlation between genetics and insomnia proves that genetics causes insomnia. For instance, they say, these results provide insights into the possible molecular basis for insomnia. And they also say, insomnia-associated loci may contribute to the genetic risk underlying a range of health conditions, including psychiatric disorders and metabolic disease. Another of the criteria in the baloney detection kit is, does the information fit with the way the world works? we can see that the authors have indeed made efforts to substantiate their findings by including other scientific evidence. One of the criteria in the baloney detection kit is, has anyone tried to disprove the claim? They say that it's important to ask, what else could explain this? Think about alternative explanations. Try to disprove your claim, otherwise someone else will. So in our article, the authors have highlighted the following limitations to the study, and this will allow us to do exactly that. By documenting the limitations of the study, the authors open up the possibility that their findings are not generalizable to all populations. For instance, it's well known that self-reporting as a way of collecting data has its limitations, because what people say and what they do is often different. It could be that people who reported being insomniacs actually didn't lose more sleep, but were instead hypochondriacs. Because most of the participants in the study were male, it might mean that the responses in females are completely different. The authors note that the risk of this occurring is likely to be low. However, because they refer to the findings of another study which reports similar conclusions, and that had more female participants, the findings of the study may also be biased by those with European heritage, which was the predominant heritage in the study sample. So the results may not apply to those from another heritage. So finally, let's go back to the original blog post. What we can conclude is that the information used to inform the blog post was reputable, sound, and based on high-quality scientific research. However, let's review what the blog post said about this high-quality study. In summary, it claimed that failure to get a good night's rest is often a family affair. So the claim they made is that sleeping patterns are genetically influenced. What the study found was that it was possible that genetics could influence insomnia, but the findings come from correlations between these two variables. This means the data can't be used to infer that genetics causes insomnia. So our blog post has sloppy scientific literacy and uses imprecise language to make a claim that isn't exactly true.